Okay, writing the equations of lines, flip lesson number 2. So in today's lesson, we're going to be looking at 2 points and writing the equation of the line that goes to the 2 points. So the first thing we're going to do is we're going to use a table to find the slope. We're going to write the point 2, 5 into the table as 2, 5, and the point 4, 9 into the table as 4, 9. And we know how to do hoops, right? We've done these in the first and second unit. We're going to do our hoops. 9 minus 5 is 4. 4 minus 2 is 2. And our slope is rise over run. So change in y is our rise that goes on the top over change in x, it's our run that goes on the bottom. And if we use the calculator to simplify, we get that our slope is 2. And so we're going to use the table. So now we have our slope, right? So we know that we're making an equation of a line with y equals mx plus b. So we're good so far, right? We know that the slope is 2. And now we just need to find what the y-intercept is. So we're going to use our table to find the y-intercept. First thing we're going to do is we're going to write our 2 points in the table. Notice that I wrote them way down here. And the reason why is that we all know that to find the y-intercept, we have to set x equal to 0, and whatever y is equal to, that will be our y-intercept. So just like we did last class, we're going to make our box around the y-intercept point, 0, comma, whatever the y ends up being, and we're going to work up the table to find what our y-intercept is. So if our slope is 2, that means as we move down the table, we're adding 2. As we move up the table, we're subtracting 2. So we want to move up the table because we want to know, hey, what happens when x is equal to 1? What happens when x is equal to 0? So 5 minus 2 is 3. 3 minus 2 is 1. So there we have it. Our y-intercept is 1, and we can finish our equation. I know what some of you are thinking when you're looking at this table. You're like, Miss Overby, if we're adding by 2 as we move down the table, right, 1 plus 2 is 3, 3 plus 2 is 5, then why is 5 plus 2 9? Well, if you notice that this table, we could go ahead and change it. We could do the 2, then the 3, then the 4. And then you would see that it's 5, 7, 9. So we had a little bit of a jumping from here to here, and that's why it looked a little funny from here to here. Okay, so that's what we're going to be doing. We're going to be looking at 2 points, using our table to find the slope, and then using a second table to find the y-intercept. So, oops, I wanted to go ahead and show you this real quickly. We could have, in this problem, we could have plotted the 2 points, drawn the line, and found the slope. But that won't always work if the numbers are too big, right? And a table will always work for us. All right, let's look at this next one. We've got 2 points, so we're going to use the table to find the slope. We're going to put 4, 5, and 6, 15 in there. Then we're going to do the hoops. 15 minus 5 is 10. 6 minus 4 is 2. And we're going to remember that the slope is rise over run. Rise is the change in y, right? That's 10. And then x is the change, run is the change in x, that's 2. And if we went ahead and simplified in our calculator, 10 divided by 2 is 5. So our slope's 5. So right away we know we've got y equals 5x. Now we just need to find the b part. And so we're going to set up our table. We're going to put our 2 points in there, and we're going to actually not even pay attention to this last point. We're just looking at this point, and we know our goal is to work all the way up till we know what the y-intercept is. And we know that the y-intercept is when x is equal to 0. So as we move up the table, we're going to want to find out, hey, what happens when x is equal to 3, x is equal to 2, x is equal to 1, and finally, what x is equal when x is equal to 0. So we're going to look at our pattern. We know that our slope is 5. That means as we move down the table, we are adding by 5. As we move up the table with the y column, we're subtracting 5. So as we move up, 5 minus 5 is 0. 0 minus 5 is negative 5. Negative 5 minus 5 is negative 10. I'm doing this in my head, and you can just slow me down or slow this video down by pausing it, picking up your calculator, and seeing that negative 5 minus 5 is negative 10. Negative 10 minus 5 is negative 15. And there we have it. That's our y-intercept. So put it up here. And so if you're wondering what is the name of the line that has these 2 points in it, we found it. Now, what if instead of, let's see how many jumps we had to make for this one. We had to make what? 1, 2, 3, 4 jumps to make it up to 0. Wonder if we had a problem where we had to make 20 jumps. Like that would be a lot, that would be a very long table and a lot of jumps. So we need a shortcut when that happens. And so what we're going to do for the shortcut is we're going to look at the same table that we just made. So this was the table from the last problem. I'm going to get rid of this part so we can kind of see really it was starting here that was important. So we made 4 jumps, right? We made 4 jumps because we did 1, 2, 3, 4 to finally get us to the y-intercept. So the shortcut is this. Step 1 is how many jumps are needed to make it back to 0. In this case, 4. What is the slope? The slope is 5. And so you have to ask yourself for step 3, does the table increase as you go up the y column? Well, let's see. 5, 0, negative 5. No, it's decreasing, right? So we're not going to use this. It decreases. Does the table decrease as you go up the y column? Yes. Then we're going to multiply jumps times slope. 4 times 5 is 20. And we're going to subtract it from the existing y value. This is our first y value. So we'd say 5 minus 20 is negative 15. Now, if you didn't like this shortcut, that's okay. We're going to practice it in class. Also, it's fine to extend a table if you have to, if you're more comfortable that way. Okay, so write the equation of the line that goes through these 2 points. All right, this is a very special kind of problem. And so what's special about it is that when we look at it, we notice something unusual. We notice that the y is equal to 3 for this point, and the y is equal to 3 for this point. Whenever we see this, we know something's up. And it's going to be, the quickest way is actually going to be turning to a graph. If we graph this point 2, 3, that'd be over 2, up 1, 2, 3. There we have it. That's the point. If we graphed 5, 3, we'd go over 5, 1, 2, 3, 4, 5, up 3. And if we connected those 2 points, whoops, okay, let me try a little bit better there. If we connected those 2 points, we know the name of this line, right? 1, 2, 3. The name of this line is y equals 3. So that's the fastest way to do it. But wonder if you didn't notice that the y's were the same and you were just on autopilot. Well, that's okay. We would still do our same steps, right? We would put 2, 3 in the table, 5, 3. We'd do our hoops to find our slope, and we'd realize, oh, our slope is 0 over 3, which if we put 0 divided by 3 in the calculator, we would get that our slope is 0. Then it says multiply jumps times slope and add or subtract to find the y-intercept. Okay, well, our slope is 0. We haven't made our table yet. Let's see, how many jumps would we have? We're going from 2 to 0. So we would have to make 2 jumps, right? So we'd make 2 jumps. 2 times 0 is 0. Okay. And we're going to subtract that from our point. So I'm not sure why I didn't include a table. Let's see if I've got a table here. If you can squeeze a little table in here so it can make sense. Let's see, we've got our 0, that's the one we're going to be looking at. We've got 1, we don't know, but we know 2 is 3. So we're going to be subtracting 0 from 3. 3 minus 0, 3. 3 minus 0, 3. Okay, so we see our y-intercept is 3. We also see that our slope is 0, so if we did it this way, we would have y equals 0x plus 3, and we would want to rewrite it as y equals 3. As you can see, when we have the same y values for both points, graphing it and coming up with the answer is the fastest way. But you can still use the other way. All right, let's see what's behind this. Or you can just look at the 2 points and notice that both y is equal to 3, and you are done. And that would look like this. Hey, y is equal to 3. Y is equal to 3. What's the name of the line? Y equals 3. There you go. 3 different ways to do the same problem. And so we're going to practice these, looking at 2 points and finding the equation of the line given those 2 points. I'm also in class going to give you a second way to solve these problems. Some people are really liking this whole jumping idea. It's very intuitive and they like the logic behind it, but some people would like a formula. I'm going to give you a formula in class to help you out. So thank you for joining me, and I look forward to seeing you in class.